Good morning. Welcome to the August webcast. We're going to be doing course ID today, ICE1107. This is going to be a NEO installation, use and care. Also, we'll go through the sequence of operation as well. Welcome. My name is Jared Glines. I'm a Territory Service Manager for Manitowoc Ice Machines. I've been with the company now for about a little over 13 years, actually coming up on 14 now. I'll be your guest host today. For those of you expecting to see John Bailey, John has taken a new position within our company. He's still with us. He is currently taking on a Territory Service Manager role out west. So John's still around, but I'll be filling in this week and potentially even next week as we go through the Crystal Craft premiere. We'll talk a little bit more about that coming up here in a little bit. So today, because of the way that these live events are set up, we don't want to have a lot of people talking over us and stuff like that. However, we want to be able to answer questions. If you have a question that comes up, there is going to be an icon somewhere on your screen currently where you can enter into the chat feature. We'll utilize this chat feature to help us be able to answer these questions. I've got Will York helping me out today. He's not only producing this, but he will be manning the questions. Thank you, Will. He's back behind the camera. He'll even jump into the shot here in a little bit. I'm going to make him come up and show his face here coming up in a little bit. Also, at the end of the seminar today, we're going to have an online quiz. We started doing this a while ago. This helps us understand how much information we're able to provide and whether or not you're able to understand what we're trying to tell you. But we want to encourage people to take these online quizzes. It's not a pass or fail. You can get them all wrong and you'll still pass the course and get the course thing. But as a reward for doing this quiz for us, we'll not only send you a virtual or a webcast training certificate for the course, we'll also send you a PDF version of today's presentation of all of the slides that you're going to see today as I go through this presentation. You'll get a copy of that in a PDF format. And that's going to be important to have that copy, as we'll find out here coming up in a little while. All right, so we're going to do the NEO UnderCounter ice machine. We're going to go over the overview of this machine. We'll discuss the installation of it. And again, we will go through the sequence of operation on this piece of equipment as well. This is not a troubleshooting webcast. This is going to be overview, installation, and sequence of operation. So on the NEO touchpad, we do have a touchpad membrane switch on the front of the machine to help us control that machine in regards to starting and stopping it, sequence of operation. We've got some other things, features and things on this unit as well. As we look at the front of it, we've got the bin door. As we open up the bin door, we can see inside this unit, we'll see the evaporator. We are going to utilize a set of float switches inside this machine. It will be a batch water system. As we go through the sequence of operation today, we'll explain how these float switches function within this machine. There will be a water trough thermistor. We'll talk a little bit about that as well. We're going to use a damper door underneath the evaporator with a magnet attached, lining up to our magnetic reed switch to tell the control board when the ice is harvested during the harvest cycle, and also to tell us when it's time to shut off on full bin. You can see the user interface control panel on the front door frame assembly of this unit. We've got the removable louvered panel at the bottom and an air filter, tool-free air filter that we can take out and clean on a regular basis so that the machine can function properly as it's installed in the location where the customer has placed that. So again, the water trough thermistor is in current production. We'll talk a little bit more about what it's responsible for, what it does for us as we go through the sequence of operation on this unit. Once we get inside to the refrigeration deck, again, some more component identification. You can still see the evaporator, the damper, and our float switches up on the evaporator, the ice making area in the food zone. But on the refrigeration deck, obviously we need to have a compressor. We're going to have a hot gas valve for our harvest cycle. We'll have a condenser, whether it's air or water cooled, to help us remove the heat from that refrigeration system. The dump valve, the water pump, the inlet valve, fan cycle switch, high pressure cutout. All of those are going to be located down in that refrigeration deck with also the control circuit, the control board on this piece of equipment as well. On the back of the unit, we do have the expansion valve is right behind the evaporator. We can see where the wires go into the back, into the food zone for those float switches and the thermistor as well. You can kind of see the water pump also in there in regards to the water pump's location. Also, all of the installation related issues or things are going to be located on the back of the unit. We will need incoming water. We'll need a drain. We'll add another drain as well. We'll talk a little bit more about that coming up in the installation portion. If it's a water-cooled unit, there will be a couple more fittings on the back of that unit to let us hook up the water-cooled condenser in order to remove heat from the refrigeration system during operation of that machine. On the control board, we did update this control board. It's been a couple of years now that we updated it. We do have 2 thermistor ports on this control board. The second thermistor port, the J10, that was placed in there for future consideration from engineering. At this point, we're still considering if we want to use it. We're not using that on any models, and so that thermistor port will not have anything plugged into it. We may or may not ever use that thermistor on the control board for J10, but it's there just in case we decide we want to utilize it. J4, that's where our water trough thermistor will plug into the machine. Again, current production does have the thermistors placed back into that water trough. We've got a test switch button where we can go into the test mode on this control board, pushing and holding that test mode button for 3 continuous seconds makes the machine go into our test mode, at which point we're going to go through a series in the test. We're going to talk more about that here in just a second. It's going to energize all of the relays on the control board for 3.5 minutes, but we also added recently, within the last year or so, additional programming to that test mode. We're going to let it act like the display bypass button on the Indigo Next control board. On the Indigo Next control board, we added a display bypass in the unlikely event you had a failed display on Indigo Next. There was a button on that control board where you could place that machine into operation for about a week's normal operation, giving you an opportunity, the service companies, an opportunity to be able to go pick up a new display, bring it back and install it on the machine, but let the machine continue to just make ice and drop ice like it was supposed to without the addition of that touchpad. So we also added that to the Neo control board. So we added this feature, so if you enter into the test mode, not only will it energize all the relays for 3.5 minutes, it will stay in normal production for about 500 cycles, which is a better part of a week, which would give you the opportunity to get the service company the ability to get a replacement touchpad or user interface if necessary, get it back installed on that machine, but allow that machine to continue to function like it's supposed to, even without that display or touchpad on it. Our asset data, our data tags, our model serial number tags, they're going to be in a couple of different places. We've got 2 asset data tags. We've got one on the back of the machine. There's also going to be one inside the machine on the right-hand side on that base. So this is going to give us our asset information. It's going to contain all of the information that we need in regards to that machine. It's going to give us our model number, our serial number. There will be a manufacturer date on there as well. It's going to tell us what refrigerant type we're using, what kind of voltage that the machine is set up for, and how much refrigerant we use within that piece of equipment also. So all of this is really important information for the servicer. We'll also have our NSF and UL approvals on that data plate as well, indicating that it is NSF and UL approved. So how does the model number break down? Well, the Neo model number will break down with the letter U as our initial model number. The first letter will be the letter U, standing for UnderCounter. This is something that we switched over to with the Neo model. Also, the second letter in our model number will indicate what kind of ice it's making. It's going to be D for dice cube, Y for a half dice cube, R for a regular cube. If you were to see an F or a N there, it would be a flake or a nugget. Of course, those aren't available in the Neo line, but we do have a flake and nugget line that is considered UnderCounter or self-storage as well. So that's going to help us determine what kind of ice we're making. Also, we started adding back in 2018 another letter to our model numbers to indicate the type of refrigerant that we were using in these machines. So going back to 2018 with the Department of Energy's requirements, the DOE 2018 Energy Initiative, on our premium line, on our Indigo Next line, we saw some new refrigerants come in that were more energy efficient. And also we had some of our machines in the Indigo Next line that already met the 2018 energy efficiency. So those stayed on the R404 like the Indigo platform had, but some of them changed to R410A, which went to a letter T for that refrigerant. Because we knew we were going to have some mixed refrigerants in these lines, we decided to add that refrigerant designator to every single one of our models, even if the refrigerant didn't change. So NEO's been R404 from day one. It remains an R404 refrigeration system. However, we started putting the letter F in there to indicate it's an R404 system so that we could remain consistent in the way that our model numbers showed up on the data plates as you're looking at our equipment. The next series will be a series as far as what the machine series is, and it's going to give you a rough estimate of its potential 24-hour production. In this case, this is a 140. It's going to tell us that this machine is capable of producing, about 140 pounds of ice every 24 hours, given the right conditions with cool water, cool air temperature around the machine. And so that's what the series number kind of roughly reflects. The next letter after that will indicate the kind of condenser that we're utilizing in that machine. If it's an A at the end, it'll be a self-contained air-cooled unit. And if it's a W, it'll be a self-contained water-cooled unit. Those are the only two condensing options that the NEO is available in, and so we'll only see air or water at the end. There's going to be a dash, and then we're going to give you your voltage nomenclature, a 1 or a 2 at the beginning, indicating it's 115 volts or 208, 230. We should pretty much see a 6 most of the time in there, indicating it's 60 hertz, 60 cycle. That's for the U.S. Of course, we are a global manufacturer, and so in European countries and things that are on 50 hertz power, you would see a 5 there. And then the next number is going to give us our phase, 1 or a 3, indicating it's a single or a 3-phase on that unit. Also, there could be a couple of things we might see at the end. The B would indicate that we do have the voltage, the 115 volt grounded power cord on there. If it's a 208, 230 unit, it won't come with that 115 volt cord on it. And so that's kind of just an additional indicator that we'll see at the end of that model number. All right, so that's our overview, kind of the component identification from a distance. On the front with the bin removed, on the back of the unit, the control board, the data plate, and also our model number breakdown in regards to our machines. So let's talk about the installation. A lot of these machines, as we go to get these units installed, sometimes they meet the requirements for installation, sometimes not so much. However, if you do have this machine, once you open it up inside, you will see the installation use and care manual in there, and it's going to cover what the requirements are and things like that to help us understand if this piece of equipment will function properly within the area that we're installing it. So first thing we want to do is make sure it's going to be located in a good area where it can have a little bit of airflow around it on a self-contained water-cooled unit. We want to make sure it's safe from any bad chemicals or something like that. This is an ice machine, potentially ice that people would be eating. So we got to be careful about where we put these machines, that they're not subject to some areas that may not be so desirable in regards to trying to consume ice. All right, the back of the machine, we do recommend 5 inches on the top and on the sides and 5 inches on the back. The sides and top, those are going to be more in regards to serviceability, making it accessible for the servicer to get to that machine. These machines are not designed to have equipment installed on top of them. Do not let the customer install something on top of these machines. It's not designed for that kind of weight. If it's underneath the counter and they want to put something on the counter, that's fine. We will need a little bit of room behind the machine for our incoming water and our drains as well. So we're definitely going to want some areas on the back of that unit to be able to plumb this unit in and also plug it in. The sides and the top, again, are more recommendations. There's no functional requirement for the tops and the sides, but it would make it a little bit easier for you or the service companies to clean these machines in order to properly maintain. This is going to be a front intake and exhaust on the self-contained air-cooled unit. So we're going to bring the air into the front of the machine and out the front of the machine. And so because of that, there is no functional requirement for the top and the sides. And so you could potentially have this thing cubby holed in underneath the counter and it wouldn't cause any functional issues. We'll talk about how you can get into this unit later if you do have a situation where it is kind of packed in kind of tight. Does not necessarily mean you can't get into service this piece of equipment. Also in the installation use and care manual, we'll give you the heat of rejection in regards to what size machine, what model it is, how much heat it's going to dump into the space. This would help your air conditioning contractors and things understand whether or not the air conditioners are capable of handling that additional heat rejection from this ice machine. The unit will also come with legs. The legs will be located inside the bin when the machine is uncrated. Once you take it out, we'll screw the legs onto the bottom. They are leveling legs. You can unscrew and screw the feet on these legs to raise and lower it. Maybe it's going on a tile floor. They're not exactly always really level. And so you can utilize those legs to make it level and make it sturdy and standing on those legs when you go to install that machine. On the back of the machine, this is something that came up new. We definitely wanted to address that today in our service webcast, but a while ago, we did have a requirement to change a little bit the drain systems on the backs of the machines. It has created some confusion in the field. We understand that. We get that part. This was out of our control. This had to do with a health department requirement. And so we do have our incoming water on the back of the unit, and then we're going to have two separate drains. We'll have a bin drain, and we'll also have the ice making water drain as well. So we'll talk a little bit more about those in regards to why that are there and the importance of having those two drains plumbed up. We cannot just simply plug one of them off, otherwise the water is going to go somewhere, and it usually comes out inside the machine and spills all over the floor. All right, so that started in 2020. We also are going to recommend you have an 8-inch vent on the ice making and bin drain. Do not vent if you have a water-cooled condenser. Do not vent that drain, as that's controlled by the water pressure going through the water regulating valve. So it's not trying to go down a drain. The pressure's bringing it through that drain, so you do not need to vent, nor do you want to vent that water-cooled condenser. Okay, so we did issue a parts and service communicator, a service bulletin, number 40. It is available on our website, but this kind of explains the addition of these second drains. We do have the potable water outlet. So this is the water that's left over at the end of the ice making cycle. This is going to be our mineral laden water that we want to get out of that machine to help keep the minerals down within that machine. But we've also got our bin drain. So as the ice slowly melts in the bin, we need somewhere for that water to go. So the bin drain will also be on the back. So we're going to run those two separately in order to be able to meet these health requirements in some parts of the country. It wasn't all parts, but we couldn't tell for sure where all these machines were going. And because there was only a requirement in some small little areas, we decided just to make the change all the way across it, because like I said, we are global, so we're just going to make them all that way so that we don't have to worry about which machines are going where in regards to where they're going to be installed in order to meet those health department requirements. Of course, we'll have our outlet for the drain if it's a water-cooled unit. So if you do have a self-contained water-cooled unit, you're going to have 3 drains coming off of that machine. We're also going to recommend that all 3 of those get ran separately. Don't try to tie them in later. We definitely want to run each one of these separately, so if we do end up with a little bit of a restriction in the drain, we don't have things backing up into the machine. We can keep it safe and keep the food safe and the ice safe within that bin of that ice maker. On our float switch system, we'll go into this a little bit more in depth during the sequence of operation. We're going to utilize a series of float switches, 2 float switches in the machine, one to tell the control board when the water trough is full, and one to tell the control board when the water in the trough has been converted to ice on the evaporator grid, and it's time to initiate the harvest cycle. So in order to adjust the ice thickness. If you want your ice a little bit thicker or a little bit thinner, you're going to raise or lower the water level in the water trough. You're going to increase or decrease the amount of water in the water trough, thereby increasing or decreasing how much ice you end up with on the evaporator grid. So that's how we'll adjust the ice thickness. It will come into from the factory in the center position. That's going to get you really close to a normal sheet of ice, an 1/8 inch bridge, pretty full cubes. But if you want your ice just a little bit thicker or maybe just a little bit thinner, we're going to raise or lower that ice thickness float switch in order to achieve that on that machine. So that's the installation. As we go through inside the installation use and care manual, let's double check. Let's make sure we've covered all of our bases. We've got the machine level. We've got the water supply done. We've got all of our drains properly plumbed on that unit so that we know for sure that when we do go to put that machine into service, that it's going to have everything that it needs, all the water in the drains and the power that it's going to require on that machine. On that data plate, again, tells us what voltage that machine will require. All right, so installation use and care manual comes with every single machine. We want to locate it in a safe, clean environment. We need to know how much heat rejection there is for the air conditioning guys to make sure that they can handle the extra heat coming into that unit. We'll level it up. We're going to supply all of the water. We're going to hook up all of our drains. We're going to verify the ice thickness, go through the checklist to make sure we're ready to go and put that machine into service. As far as the cleaning and sanitizing, this is one of the things that we really wanted to cover today. One of the #1 causes of ice machine problems is just a desperate need for a good cleaning. A lot of customers, they got a lot of stuff going on. They really don't think about the preventative maintenance or the normal preventative maintenance on their ice machines until it starts to cause a problem. All of a sudden, now it's important. But it's also very important to make sure you have regularly scheduled maintenance so that you don't have those down times when the machine starts to get dirty and can't function properly. So we've designed this machine so that the customers could actually clean it themselves if they wanted to try to do that. And so it's going to come apart fairly easily and be able to be cleaned and sanitized so that the customer potentially may actually want to try to do this themselves. Maybe not. Maybe they wouldn't want to do it themselves, but ultimately, if they don't want to do it, we've made it easier for the service technicians as well that come in to clean this equipment. So we're only going to utilize our Manitowoc nickel safe ice machine cleaner and Manitowoc sanitizer. We get a lot of calls into technical support. Hey, can I use this cleaner? Can I use this sanitizer? The answer officially is going to be not really, because we know ours work, so we never bothered to test them. We can't tell if those will damage it or not, the nickel plating or the plastics and stuff. So we're only going to recommend our cleaner and our sanitizer. The others we haven't tested. So if you want to utilize somebody else's cleaner or sanitizer, you're going to do that at your own risk. But we do have our own cleaner and sanitizer, which is going to help us make sure that we can properly maintain that equipment. The cleaner is used for lime scale and mineral buildup and things like that. The sanitizer is going to be used for disinfecting. Maybe you get a little bit of cold water slime, a little mold or mildew, things like that. That's what the sanitizer is there for. So they're going to attack different kinds of cleaning. So don't try to use nickel safe ice machine cleaner if everything's all slimy. That's going to be a sanitizer type of a situation. Also, just as a side note, Luminice is available for the Neo UnderCounter ice machine. So if you do have a situation where you're getting a lot of slime, a lot of mold or mildew buildup or things like that, the Luminice is available for Neo and could be installed to help combat that in the event that you have something in that situation. Also, be careful. These are chemicals, and so you'll only want to use them according to the directions and not in any other way, because it could cause damage to things or potentially to you. It is considered food safe cleaner and sanitizer, but don't drink it. It's not like that licorice flavored stuff that they sell you on the street when they go door to door. It's not edible. We're only going to utilize it to clean that machine. So as we go through the clean sequence of operation, We'll go ahead and start the clean sequence by pushing and holding the clean button for 3 continuous seconds. Once we do that, we'll initiate the clean cycle. As a side note, the machine needs to be turned off. It cannot be in the ice making in order to go into clean. So you'll turn off the machine. You can turn the clean button on by holding it for 3 seconds. As soon as we do that, we'll energize the dump valve. We'll get whatever water's inside the water trough out. We'll fill up the water. Once the water's full, the water pump's going to kick on and start to circulate the water. This is when we would add our chemical. The installation use and care manual, section 4, is dedicated solely to the cleaning and maintenance of this machine on the installation use and care manual. So as soon as that water pump kicks on, we're going to add our solution that we've prepared for this unit. And it's going to circulate for 10 minutes. That's going to take 10 minutes to circulate throughout the evaporator and the water system. It's going to get inside the water pump, all of the tubes. It's going to clean everything inside that entire water system, the stuff that you can't see. Once it gets done, it's going to dump that down the drain, and then it's going to go through a series of 6 fills, rinses, and flushes. We want to make sure all of that gets rinsed out of that unit and down the drain so that when we go to place this machine back into operation, we don't have any leftover cleaner or sanitizer on that machine. Once it gets done, it'll turn off and the machine will go ahead and wait for further input. We can also turn that machine back on to automatically start making ice by pushing the power button while it's in that clean cycle. Once we've done that, we're going to want to disassemble the machine. Yeah, we just ran all that water through. We went through all the water system, all the hoses and the water pump and things like that. But then water also gets in places that maybe the water in the water trough or circulating through the machine may not be accessible during that clean cycle. So we'll want to disassemble the unit in order to finish the cleaning. We want to clean all of these components separately. We'll take the water ice thickness float switch and our harvest float switch out of the unit. They just clip onto the side of that water trough. You pull out that little rubber grommet on the back of the unit. You can access the poke-yoke connectors in behind there and disconnect those float switches and remove them completely from the machine so that you can clean them physically. All right. We can also go ahead and disconnect that water trough thermistor. Also, these are a magnetic float switch. I know Will was getting ready to zoom in, but maybe we'll go ahead and zoom in for just a moment here on these float switches. So it's got a magnetic reed switch inside this float switch. There's magnets within this bulb, and as that bulb moves up and down, it's going to open and close the contacts. Up is open and down is closed. However, there's also a clip here that you can remove from the bottom of this float switch so that you can remove that bulb from the switch. In case there's a bunch of gunk and stuff in there, you can take that bulb off and get everything cleaned up really good. However, if you flip that bulb over and put it back on in the wrong direction, it's going to change the orientation of the switch. It's going to make the up position closed and the down position open, and it's not going to function properly. So what I recommend is if you are going to take these apart to clean them, before you take that little clip off the bottom, just make a little mark, maybe with a Sharpie or something, on which one is on which end is on the top. And then that way, when you go to put it back, you get it in the right position. Let's face it, you got a 50-50 chance, all right? But even those are really good odds. I am never that lucky, so I would get it wrong most of the time in that case. So be careful when you do that. Maybe make a little mark on it indicating which end was up before you take those apart. We can also remove the water trough by removing 2 of the thumb screws. They are thumb screws, so that we can unscrew that water trough, take it off the bottom of that evaporator area, and be able to clean physically that water trough. The damper will come off. There's a thumb screw on the right-hand side where the magnetic reed switch lines up and the magnet on the damper. By removing that magnet, we can take that damper right out of there and get in there and take these components all to the sink, take it to our solution and clean it. We've also got the removable water distribution tube on top of the evaporator where we can get in there and utilize our solution and that 3-compartment sink also to get the additional minerals or slime or whatever it is that we're trying to clean off of that machine off of those individual components. Also, we can get into the air filter. On the air filter, it is removable by just simply pulling down. It clips into place. No tools are required. In the event that that starts to get plugged up, we can take it off. It is a mesh screen, so we can utilize a little bit of warm water if necessary, a shop vac, whatever you need to do in order to clean that. Don't run it through your dishwasher or anything like that, but we can clean that to make sure we've got sufficient airflow through the condenser during operation, because this machine definitely needs to have the ability to breathe inside there. So making sure that air filter is clean really does help a lot in the regards to the operation of this piece of equipment. We can also remove the top cover if we do have the machine not installed underneath the counter. We can remove the top cover just simply by removing 2 5/16" screws. This will give us the ability to remove that top cover and get into the evaporator area in case we want to not sit on our knees and reach inside the bin trying to disassemble all of the components. We can access the top of the evaporator compartment by removing that top cover with just 2 5/16" screws removed. And then that way we can get in there and disassemble it. Maybe a little bit easier in regards to this preventative maintenance and the cleaning position. However, the bin is also removable. Maybe we do have the machine installed underneath the counter, and so we want to be able to get in there and get better access to all of these components for cleaning. And so we do have the ability to remove the bin. We'll take off the louvered panel on the front. There's a couple of clips on there as well that we'll need to undo in order for the bin to release from the base. We definitely want to disconnect the drain that goes to the bin. Otherwise, when we go to remove the bin, it's still hooked up to the drain and it won't go anywhere. And also, for sure, make sure we disconnect the ribbon cable that goes from the control board in that control box area up to the user interface on the front of the unit. Once we've got all of those disconnects done, there's just the 4 things: the louvered panel, the clips, the drain, and the communication cable. We have the ability to then slide that bin directly off the front of the machine and put it out of the way. And we're going to give us access to all of the refrigeration components and things like that. We get into the evaporator for disassembly, for preventative maintenance. Maybe we need to service it. Maybe we're going to get in there, or the service technician needs to get in there to repair or replace a failed component. This gives them the access and the ability to get in there and get to all that. And so it makes it a lot more easy to service this piece of equipment. And that's why that 5 inches on top and bottom are more recommendations, not a functional issue. Worst case scenario, we could go ahead and get in there by removing that bin, and that would give us the ability to get in there. So as we go into the review on the interior, we're going to clean, we're going to sanitize, we're going to remove all those parts for disassembly and removal. One of the things that does come into technical support phone lines quite a bit is, I didn't know the bin came off. How do I get back there to clean the condenser? How do I get back there to service this piece of equipment? So what we're going to do is we're going to take just a couple of minutes. I'm going to show you how to remove the bin from the base of this ice machine. I will need Will's help here in just a minute, but we're going to go through the disassembly and removal of the bin on this machine. So you will need a 5/16" nut driver. The 5/16" nut driver is going to be the common size. Now, in all fairness, I got a head start. I've loosened everything up. I've got everything done. Just for the interest of time, we don't want to have too much time of you watching me take screws out. So we're going to get our 5/16" nut driver, and we're going to remove the 2 screws that hold this louvered panel in place on the front of the machine. Once we've got that off, and you can see the removable air filter here, where we can take that clip and open it up and allow that air filter to come out in order to clean it. Now we're going to go to our 2 clips. There's a set screw on the bottom. So the set screws on the bottom need to come completely out. Those are going to come all the way out. I typically just set them right here on the base of that machine so I don't kick them underneath the unit. I'll just put them right inside that control box area. Now, there's another screw at the top on this clip that all we need to do is loosen it. Once we loosen that screw, it allows these clips to slide down and stop holding the bin in place. We definitely want to get in here on the drain. We'll disconnect the drain from the bin, and definitely don't forget this. We want to get in here and unclip the harness that comes up to our user interface. There is a control box cover. Like I said, I got a head start on it for the interest of time, so you would have to open up the control box cover in order to get to that. Once those are all done, now the bin is completely free from the base. So Will's going to join me real quick because it is elevated, and I don't want to hurt myself. So we're going to slide this off, and it slides. There are a couple of tracks, and then we can set it out of the way. Okay, be careful not to set it on the communication cable. Once that bin is removed, now you have access to a lot of the components in here. Maybe somebody took the air filter out to clean it and forgot to put it in. So all that dirt and stuff ended up on the condenser. Well, guess what? Look how easy it is to get into this condenser now to clean it with that bin off. Also, you can see your dump valve here. The water inlet valve's kind of hidden down there on the bottom. Here's the water pump. You can kind of see those float switches again. But we can now go ahead and disassemble this machine for cleaning very easily because we now have access to it. In the unlikely event you have a refrigeration problem, the service technician can get in here to access the refrigeration ports and additional items. The control box systems here. I don't know if you can see it or not, but one of your data plates is on the inside of that base of the machine, and it's that easy to remove the bin. And so when you do go to put it back on, though, remember it is on tracks. You'll want to start it on the back and slide it in so that it mounts and is held in there tight. Also, we're going to show real quick the top cover removal. There's just the two 5/16" screws on the back of the units if you do have it not installed under a counter. But as you notice, we took that bin off without removing the top cover. So the top cover does not have to come off in order to get to the bin. But now that I've got those two screws out, I can remove that top cover, and maybe, just maybe, I wanted to clean this machine and I had access to it. And then you kind of have to realize that now I would have direct access to the top of that unit for preventative maintenance. So all of this stuff is designed to come off, to be easily accessible, to make this machine easy to clean, so that we can keep these things well maintained so that the unit can function properly and give us a lot of years of service in regards to that. You see your condenser fan motor, compressor. So that's the inside of that unit, and that's how easy it is to get to. So we're going to now go through the sequence of operation. Sequence of operation is important for a lot of us because, frankly, if we don't know what that ice machine is supposed to be doing and when it's supposed to be doing it from a service side of it, it's going to be hard to figure out what's wrong with it if we don't know what it's supposed to be doing. So the sequence of operation is vitally important on all pieces of equipment, not just ice machines, but for ice machines, we feel like the sequence is very important so that we can tell when the machine may not be doing what it's supposed to be doing and help us identify and correct any problems that may exist in there. Okay, our control board touchpad features. We have a power button, the universal symbol for power. It's got blue on that button as well. This will turn the machine on and off. This starts and stops the sequence of operation. We have to push and hold it for 3 continuous seconds in order to turn the machine off. This prevents somebody from bumping into it and accidentally turning the machine off. You'd have to bump into it for a full 3 seconds in order for the machine to turn off. There is a delay button on there with blue LEDs below it. You can enter the machine into a delay feature for 4, 12, or 24 hours. A lot of these little Neo machines end up in small businesses maybe where their break room kind of also serves as their conference room or their meeting room because it's got some tables and a chair. So what they'll do is from time to time, they'd go in there, the machine's running, they turned it off because it was noisy during their meeting, and then somebody forget to turn it back on. The delay button allows you to delay that machine off for 4, 12, or 24 hours so that if you forget to turn it back on, it'll come back on all by itself. The clean button, of course, clean button, we have to push and hold it for 3 seconds to start the clean sequence. We went through the clean sequence of operation. Essentially, it's going to wash for 10 minutes and then go through a series of 6 rinses and flushes. Also on the user interface, there's blue LEDs behind a sideways cutout view of that Neo ice machine with some ice cubes in it. That's going to line up with the magnetic read switch. It'll tell you when the damper is open, when the machine is off on a full bin. But then we've also got our service icon. The service icon can either be flashing, indicating the machine is sensing an issue, or it's going to be solid, telling us that the machine has sensed and exceeded one of its service limits and has got to shut off. It says, hey, something's really wrong here. I turned myself off to protect myself. Something, we need to figure out what's going on and be able to rectify that situation so we can allow the machine to keep working. On the control board, we have 2 control systems, or 2 portions of the control board, I should say. We have a low voltage or input side, and then we have our line voltage or output side of the control board. So the sequence of operation, the control board is programmed to do things based on time and also what the sequence of operation and its input devices are telling it to do. So is it supposed to be bringing in water? Well, I'm going to look at my water or ice thickness float switch to see if it's telling me that the water trough is full or not. If it's not, I'll bring in water. And so that's kind of how the control board works. Typically, the control boards do not have minds of their own. If the control board is typically condemned, it's a lot of times because an input device was making the control board do things that the service technician didn't think it should be doing. But the control boards are pretty decent in regards to the longevity and the operation. It's usually the input devices that make the control board get in trouble. All right, we've got our output display here. We've got some LEDs next to our relays. We also printed on the control board what that relay is responsible for energizing in that machine. So if you are looking at the control board and looking at one of those LEDs, hey, is my water pump supposed to be running? You would find that relay labeled water pump. If the red light was lit up next to that relay, then yeah, your water pump is supposed to be running. If it's not lit, then no, it's not supposed to be running right now. So we can kind of see that. This is more from a service side, but maybe potentially a maintenance guy or even the end user could be looking at this information. We've got a lot of LED indicators for our input devices, for our ice thickness float switch, our harvest float switch, our curtain switch. All of those are spelled out on the board. They're light up and go off based upon whether or not that float switch or those switches, input devices are open or closed. We can see if the machine's in a harvest cycle. We can see if it's in a clean cycle. All of that information is available to us on that control board. So in order to start the sequence of operation, this may come as a surprise to some, but you will have to physically turn the power button on. You'll have to push the power button to start that machine. Also keep in mind the damper door underneath the evaporator must be in place in order for that machine to start. Also, we are going to include the water trough thermistor and what it does in the sequence of operation for us. We did have years and years ago, we kind of saw some issues with that water trough thermistor. That's all been resolved. We're in full production with those water trough thermistors again. And so because of that, we will go through the sequence with the water trough thermistor in that unit. So we're going to turn that machine on. The first thing we want to do is purge the water. If there's any water left over in the water trough, we're going to energize the dump valve and try to get rid of it. Like it or not, ice is a food. So as an ice machine manufacturer, anytime we start these machines up from a stop, we'll always err on the side of caution and try to get rid of whatever water might be in that water trough and get it down the drain, because we want to, as we go to make ice, only use clean, fresh water to do this. Maybe it's going to be consumed in one form or another, and so we're always going to err on the side of caution. This purge should almost have a slash equalization, because during the 20-second purge cycle, We'll also energize the harvest valve. This allows the high and the low side refrigeration pressures to begin to equalize within that refrigeration system. So as we go to energize the contactor to bring the compressor on, we can do that easily by having pressures equalized on each side of that refrigeration system to get that motor and the compressor started, get it running, get it up to speed with little or no effort. At the end of the 20-second purge, we'll go ahead and start up the refrigeration system. We're going to energize the contactor coil. This will send the voltage out to that compressor, but we're going to keep the harvest valve energized an additional 5 seconds. Again, a no load, a low load, a soft start, call it whatever you want. It's exactly what we're doing. We're getting that compressor started up with little or no effort so that it can begin to function as we want it to within that machine. As we bring on that compressor and go into the next stage of the sequence of operation, we're now going to go into a pre-chill. Pre-chill is going to be a situation where the compressor is running. We'll de-energize the hot gas valve, allow that compressor to begin pumping and moving refrigerant throughout the system. However, we're not going to be running any water over the grid. We're simply going to allow the evaporator plate to get cold. The pre-chill is in there. We've been using a pre-chill at Manitowoc now for several decades. And the reason why we utilize a pre-chill is because of the potential for slushing in an ice machine. Believe it or not, slushing in an ice machine is considered a normal occurrence. All right, and so because it is a normal occurrence, we do our best to try to get past that by utilizing this pre-chill. And so what I'm going to do is I'm explaining why ice machines slush up. And if you do have a situation where the ice machine keeps slushing up, I'm going to tell you the best way to get past that. So what happens is during the freeze cycle, as the water is going across the evaporator grid, if the air in front of that evaporator is too warm, when that water reaches that freezing point, 32 degrees Fahrenheit, it's going to freeze. But if that air temperature is too warm, as that water freezes, that warmer temperature prevents the ice from sticking to the plate, and it comes off into the water trough in what we refer to as slush. So during the pre-chill, we're not necessarily trying to get the plate cold. We're trying to get the air out in front of that plate cold. And so by getting that plate really cold and allowing that air to kind of go out and chill down in front of the plate, when we do go to start that water pump and start making ice, that air temperature should be low enough to where we can let that ice stick to the plate and form ice on the plate, and not in our water trough in the form of slush. The most likely place you'll see a slushing event in any ice machine is on a brand new installation or a machine that's been off for a long time, because that's when those air temperatures are colder. So on the initial warmer. So on the initial pre-chill, because that's where the highest potential is, we're going to go a full 2 minutes running that compressor with no water going over the evaporator grid. Try to get that air good and cold out in front of the evaporator grid. Once we've made a sheet of ice and it drops and we go into another cycle, well, the ice that just dropped into the bin, it's helping keep those air temperatures down a little bit. And so we'll go ahead and drop down to a 60-second pre-chill after that because our potential for slushing now is kind of going down now. So we're not going to have as much slush potential on that unit. We'll also energize the water inlet valve. We'll start filling up that water trough for that clean, fresh water in order to make that ice. The control board will be looking for information from the ice thickness float switch to tell it when the water trough is full and when it's time to turn off the water inlet valve. All right, we'll also have a little bit of a delay once that ice thickness float switch is satisfied. So don't worry, it's because the water will be a little bit moving around in there. We want to make sure we got a good full water trough to make the ice with. Now that we've gone through the pre-chill, it's time to start making ice. We're going to keep the contactor coil energized with the compressor running. The fan may or may not be running, depends on the head pressure. That'll be controlled through a fan cycle switch on a self-contained air-cooled unit. As soon as we energize the water pump will start pumping water up over the evaporator grid. This will cause the water in the water trough to drop down. Control board will recognize that the ice thickness float switch dropped down. It'll re-energize the water inlet valve, again, looking for information from that ice thickness float switch to tell it when the water trough is full. However, it has a maximum amount of time of 2 minutes to fill up that water trough. It doesn't take that long to fill up that water trough. And if after 2 minutes the control board has not seen that ice thickness float switch satisfied, it'll de-energize the water inlet valve based on time, because we don't want that water trough overflowing in the event that our ice thickness float switch is not giving the control board good information. As the water is going across the evaporator grid, our refrigeration system is removing the heat from the water. It's getting cold. It's freezing to the evaporator grid. We're going to stay in that freeze cycle till one of two things happens. What we expect to see happen is we convert all of the water in the water trough to ice on the evaporator grid. All right, that'll allow the harvest float switch to close. The other thing that could happen is we could stay in a freeze cycle for a maximum amount of time. The maximum freeze time is 45 minutes. We're only going to allow that machine to stay in the freeze cycle for 45 minutes. If it still has not seen the harvest float switch close after 45 minutes, the control board will initiate a harvest cycle based on time on its own. All right, the water trough thermistor is in there because of the way that slushing occurs, because it is based upon air temperature in front of the evaporator grid. The Neo UnderCounter ice machine, we utilize a damper. We don't have a water curtain in front of the evaporator like we do on our larger modular units. And so we got to get the air a little bit colder, a little further away. We don't have a water curtain to kind of hold that colder air in close. Plus, if you remember, as soon as we open up that front door, the air is right in front. That front door opens up right directly in front of the evaporator grid. So under normal usage, customers just getting ice out are allowing these warmer temperatures to come into that evaporator compartment. So as a result, because the bin door opened directly in front of the evaporator grid, and because we don't have a water curtain to hold that that colder air close to the evaporator, Neo had a higher potential for slushing than some of the other ones, and we realized that. So what we decided to do was we decided to add this water trough thermistor. We know exactly when an ice machine is going to slush, if it's going to slush. They won't always slush, but if it's going to happen, we know exactly when that's going to happen, and that is when that water temperature in the water trough hits 34 degrees Fahrenheit. Once the water temperature in the water trough hits 34 degrees Fahrenheit, we know that the next time that the water pump pumps that 34-degree water up to the distribution tube and it crosses across the evaporator grid, we can get 2 more degrees out of it, which means we can reach the point of freezing. Well, this might be where we could potentially have a slushing event. So the water trough thermistor is going to tell the control board, hey, we're at 34 degrees, turn off the water pump. Okay? It's going to turn off the water pump. We're going to call it a pump pause. By turning off the water pump with the refrigeration system running, we're going to give this machine another little bit of a pre-chill for 25 seconds, allowing that air to get cold out in front of that evaporator again. At the end of that 25-second pause, the control board will re-energize the water pump and energize the water inlet valve for 7 seconds, regardless of what position the float switches are in. Because if we did by somehow end up with a little bit of those ice crystals that slush in the water trough, nothing moves it faster than a shot of fresh water. So we'll pause the pump for 25 seconds, let the air temperature get cold, but when the pump kicks back on, 7 seconds of water into that water trough, just in case we did end up with a little bit of slush, get everything moving so we can keep that water circulating over the evaporator grid and freezing ice to the evaporator, not having it in the water trough. Okay, if by some chance the water trough thermistor doesn't function properly or it falls out of range, the control board's not going to know when the water temperature hits 34 degrees. So we still find the benefit for having this second pre-chill or this pump pause. So if the control board senses the water trough thermistor is out of range, it's going to base it on our best guess for time. And so it's going to utilize 3 minutes and 45 seconds into the freeze cycle. So 3 minutes and 45 seconds after the water pump kicks on. If the thermistor is out of range, the control board is going to say, I'm going to do my pump pause based on time. We'll still get that 7-second fill from the control board at the end of that 25-second pump pause, but we did want to have the benefit of having that second pre-chill as we go in there, so we can help prevent the ice from forming in the trough in the form of slush and allow that ice to build up on the plate. All right, so if the harvest flow switch does not drop, the control board again, will initiate a harvest cycle based on a 45-second maximum freeze time, or 45-minute, excuse me, maximum freeze time. But again, we're looking for information from the harvest flow switch. So how does this work? It's a batch water system. One's going to tell the control board when the water trough is full. That's our ice thickness float switch. That's the one with the black wires in there. And as that water inlet valve energizes, that water trough will fill up. And once that bulb lifts up, it's going to open the set of contacts within that ice thickness float switch, telling the control board it is has got a full trough of water. Time to stop bringing in water. Turn off your water inlet valve. Again, it's going to only look for that for 2 minutes. We'll only keep that water inlet valve energized for 2 minutes. All right, at the end of our pump pause, whether we went into a pump pause based upon our water trough thermistor or based on the 3-minute 45-second time if the thermistor is out of range, when we re-energize the water pump, again, we'll energize the inlet valve for 7 continuous seconds. Again, regardless of what position those float switches are in, it's all factored into our ice thickness. And so it's not going to make your ice uber thick. It's all part of the sequence and part of that programming. And so the ice thickness is based upon having that 7-second shot of fresh water at the end of our pump pause. Once we've converted all the water in the water trough to ice on the evaporator grid, it's going to allow our harvest float switch to close. This is not adjustable. It needs to be in the same position so that we're initiating the harvest cycle once all that water has been converted to ice on the evaporator grid. It will need to stay closed for about 10 seconds in order for the control board to recognize that it's time for it to initiate the harvest cycle. As we go into the harvest cycle, the contactor coil remains energized. We still need the refrigeration system running. But now we're going to energize the harvest valve. We're going to allow the hot gas coming off the compressor discharge line direct access to the evaporator to warm up the evaporator grid, to melt the bond between the ice and the evaporator so that the ice can release. Another thing that was added to the 2018 Department of Energy requirements was the dump valve. They weren't looking at just energy requirements. They also looked to see how much water the machine was using. Because our dump valve was below the water trough, we were using just a little bit too much water to meet the 2018 Department of Energy requirements. So we did change on the control board. We'll only energize the dump valve every 3rd cycle on this unit. So it'll always be on the initial cycle, but then it'll only energize every 3rd cycle as we go through that sequence. So I get it, this can cause a little bit of confusion because the water will not go down the drain on every single cycle, but we'll always do it on the initial cycle. Ice is a food. We definitely want to make sure that we use clean, fresh water to make the ice with, and so it's going to energize on the initial one, but now we'll only do it every 3rd cycle. We get it. So there's parts of this country where your water is just really, really hard. This every 3rd cycle, it's not keeping that mineral-laden water out of the machine very well. And so we do have a way to get past that. And so in order to do that, you're going to engage it so that we're dumping on every single cycle. We'll do that right there at the user interface by push and hold the clean button for at least 3 seconds while the machine is making ice. All right. At which point we'll push the timer, the delay timer momentarily. The service light will flash. If it flashes 5 times, we've got it set up to do it every single cycle, every single harvest. If it flashes 6 times, it'll be on the every 3rd harvest. So there is a way to get past that to allow us to be able to put that into bypass. I told you there was going to be a real good reason for you to go ahead and complete the quiz at the end of the seminar today, because you'll get a PDF on this and it'll tell you how to bypass that every 3rd cycle on the dump for the 2018. All right, so as we go into the harvest cycle, again, the harvest valve is energized. We have a 7-minute maximum harvest cycle included with this. The 7-minute harvest cycle will also include a water assist, but the control board's looking for the damper underneath that evaporator to open, telling the control board that the ice came off. But this 7-minute harvest will also include a water assist. We still figure that a majority of our machines will be able to harvest within the first 3.5 minutes of the cycle, like they have been for decades. All right, but in some cases, maybe the machine's a little bit dirty. Excuse me. It needs a little bit more time, and so at 3.5 minutes, if the control board has not seen the damper open, it'll go ahead and energize the inlet valve, start filling up the water trough with clean, fresh water. 30 seconds later, it'll kick the water pump on to see if that rush of fresh water will help it release that ice. We'll keep that water pump running up until the 6.5 minute mark of harvest, at which point we'll energize the dump valve and allow that water to go down the drain. However, at any point during that harvest, the entire 7-minute harvest, if that damper opens, telling the control board the ice came off, that will terminate the harvest. If the damper does not open after 7 minutes, we'll go into a thaw cycle where we'll essentially run water over the evaporator for a couple of cycles with the refrigeration system off to try to get that ice off the evaporator. If the ice comes off, it hits the damper and the damper is allowed to close, that tells the board, okay, the ice came off, it's now in the bin where we can get to it, but because the damper was allowed to close within 30 seconds, that means, hey, I got more room to put ice. I'm going to go back to pre-chill and start another ice making sequence. We'll do a 60-second pre-chill this time. And we'll keep on doing that throughout the cycles. We'll continue as long as that damper opens and closes within 30 seconds. We'll continue going back to the pre-chill. However, eventually the bin fills up with ice. The last sheet of ice came off the evaporator grid. It allowed that, didn't allow the damper to close within the 30 seconds. That tells the control board, all right, I got nowhere else to put ice now. It's time for me to shut off on a full bin. We'll de-energize everything within the system. There'll be a 3-minute delay prior to a restart. So if you see the machine shut down and you reach in there and you pull the ice away and the damper allows to close, once that damper is closed and the 3-minute delay is expired, that's when we'll restart the machine all the way back at the beginning in the purge cycle, because ice is a food and we always want to start with clean, fresh water anytime we start in the stop, from the stop portion. All right. Again, the harvest cycle does have the thaw cycle, and that's only in the event that we do not see the damper open within the 7 minutes. It'll go through a couple of rinses and flushes, trying to melt the ice off the evaporator grid to prevent us from building double batches of ice on the evaporator and getting a big old chunk of ice on that evaporator. So that's the sequence of operation. We've gone through it. The good news is most of our cubers follow very similar sequences of operations, just a little tweak here and there, and what control systems and input devices we're looking for in order to tell the control board what's taking place inside that machine. We're also going to remind you that we do have a service training update 1 week from today. I've already agreed to do it. I will be hosting, and will be helping me. We're going to host our first troubleshooting service webcast for the new Crystal Craft USC 50 coming out. It's available right now. It's a square cube unit, and so we're going to go through it. We'll kind of go through the sequence of operation and the troubleshooting on the USC, this new square cube that is now available. Also coming up in September, we're going to talk about the automatic cleaning systems. We always refer to it as the aux cleaning system. We're going to go through the installation of the automatic cleaning system in September. So hopefully you're going to look forward to this. We're going to come up and attend these webcasts. Again, we will continue to put the recorded versions out there for your convenience, because we know it's hard to hit these live every single time. But we've also got additional training available. We've got our online self-taught training. You can sign up for the monthly webcasts on our website, manitowoc.com. Go to the service menu, click on the training. We've got some videos out there. We've got troubleshooting videos, how-to videos, sequence of operation, cleaning and sanitizing, things like that. We continue to try to develop additional videos and webinars and things to make sure that we're getting as much information out to everybody as we can in order to be able to help you understand how the equipment works and how to work on it. Again, videos are also available We'll continue to develop more and more videos as time allows, and try to make it a lot easier for everybody to get this information on these machines. So we did release some new videos, updating software and things like that, the night off program, a couple of other things as well. So if there's information that you're looking for, go out, check the website out from time to time and see if there's a new video. We'll try to announce those as they do become available, but we'll do our best to try to make sure everybody gets all of the information that they need. Now, I did go a little bit over. I apologize. I know that your time is very valuable. However, we're going to go ahead and set the quiz. There's a QR code showing up on the screen right now. We'll also post it in the comments section, a link if you just want to do it from your computer and not your smartphone. Again, you can go ahead and scan that, take that quiz, put your email address in there, and submit your quiz. As a reward for submitting and taking the quiz, you will get not only a certificate, you're also going to get a PDF version of today's program. I'd like to thank everybody for joining us today. Appreciate all that you guys do out there in the field. We're here if you need us. If you want to ask any more questions, we'll be on the chat feature for a little bit longer. Thank you so much. Have a great rest of the week, and I hope everybody is planning on coming next Tuesday, same time, when we do the Crystal Craft Premiere webcast. Thanks a lot.